Hello friends, welcome back to our channel EASI. Everything about semiconductor industry or everything that you need to know about semiconductor industry. So today we are going to talk about different kinds of xPUs, starting from CPUs to LPUs and many more. So let's get started. In one of our previous sessions, we have talked about semiconductor end products, the details of which you will find in the description below. Today, we will talk about different kinds of xPUs. So to start with, what are xPUs? xPU is a collective term for specialized processing units designed for different computational tasks. In modern heterogeneous computing, various processors work together in order to handle specific workloads efficiently. And that's what we are going to talk about today. Let's start with the most common one, that is the CPUs or the Central Processing Unit. The CPU is the general purpose processing unit or commonly called as the brain of computing devices. It features few but powerful cores with complex logic control optimized for sequential task execution. CPUs excel at handling diverse operations that requires flexibility and precision. Most common use of CPUs are in OS management and applications, where it handles operating system tasks, runs general applications, and manages system resource efficiently. And in logic and sequential processing, where it excels at complex decision making, branching logic, and tasks requiring low latency responses. Now let's touch base upon CPU architecture and performance. Modern day CPUs feature multiple cores that enables parallel task execution, and on the other hand, the cache hierarchy helps to reduce latency by keeping frequently accessed data close to cores. Thus, higher core count along with cache hierarchy helps to improve CPU performance. Next is the recent day hot topic, which is GPU or the graphics processing unit. Originally, GPUs were designed for rendering graphics and images, but over time they have evolved into powerful parallel processing engines. Their highly parallel structure with thousands of cores make them ideal for tasks requiring massive and simultaneous calculations. GPUs are mostly used in AI and machine learning and scientific computation, which requires massive parallel computing. Key features of GPU architectures are massive parallel design and streaming multiprocessors. GPUs contain thousands of smaller cores optimized for parallel data processing, enabling simultaneous execution of many operations at once. While on the other hand, streaming multiprocessors or SMs group cores together with shared memory and schedulers, thus optimizing for high throughput rather than low latency in computer tasks. Next, let's talk about the tensor processing unit or the TPUs. TPUs were the custom designed processors which were created by Google specifically for accelerating machine learning workloads. Main objective of TPU is to accelerate tensor math operations in neural network training and interface. They are also deployed in TPU pods within Google data centers, which powers AI service at a massive scale. TPUs comprise of systolic arrays that enable efficient matrix operations by flowing data through processing elements in a coordinated pattern. It uses 8 or 16-bit calculations instead of 32 that dramatically improves AI efficiency while maintaining accuracy. The modern day application of TPUs are power image recognition systems, LLM models, and real-time translation services. Next is the Logic Processing Unit or LPU. These are specialized processors for logic-intensive computation beyond the traditional CPUs. The key use cases include AI reasoning, decision making, and complex rule evaluation. The architecture is tailored for dynamic logic processing tasks. Beyond CPU, GPU, and the TPUs, there are few more specialized processors. Say for example, FPGA, these are the field programmable gate array. These are the customized hardware acceleration with reprogrammable logic for specific workloads. Then there are NPUs or the neural processing unit. These are dedicated AI interface acceleration optimized for neural network computation. There are also DPUs or the data processing units which offloads network, storage and security tasks from CPU to the data center. Apart from that, there are few more emerging xPUs which are specific for a particular computational demand. Different xPUs excel in specific domain that enables optimized performance across diverse industry applications. Say for example, TPUs and NPUs power data centers for training and interface workloads. On the other hand, GPUs deliver high performance graphics, simulations, and real-time rendering. CPUs and DPUs manage virtualization, networking, and storage offloading, and LPUs, FPGAs enable specialized processing for IoT and embedded system. So with that, we have come to an end to our today's session. In our next video, we will bring few more exciting topics on semiconductor. So till then, stay safe and stay healthy.